All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies class, I've been creating a series of video presentations based on the Mozilla Developer Network's Learn Web Development series. I'm in JavaScript, and I'm talking asynchronous JavaScript. And as you can see in this article, we are introducing asynchronous JavaScript, although we actually had an introduction to it previously. In this article, we briefly recap the problems associated with synchronous JavaScript and take a first look at some of the different asynchronous techniques you'll encounter, showing how they can help us solve basically blocking types of problems. So, to fully understand asynchronous JavaScript, and notice we've got here, there is a whole thing on asynchronous, probably better than the one I gave you earlier, and there's another one on synchronous. All right. So to allow us to understand what asynchronous JavaScript is, we ought to start off by making sure we understand what synchronous JavaScript is. So this section, as mentioned, recaps some of the information we have looked at previously. All right. A lot of the functionality we've looked at in previous learning modules is synchronous. You run some code and the result is returned as soon as the browser can do so. It says, let's look at a simple example here. All right, let's grab that source. I'm going to get rid of this, and I'm going to take this and replace it right here. All right, so I've replaced that, and what do we have in here? Well, this is our JavaScript right there. So we've got a button that says click me. We're setting up a JavaScript variable that's based on that button. All right. Let's see. Then we're setting up an event listener, which says when the button is clicked, we want it to say you clicked me. All right, we'll have a little bit more to say about that in just a minute. So let's take this. Okay, and you clicked me came up right away. When we close that, we've got this is a newly added paragraph. All right. So this came up right away, and then a little bit later, this came up. Now, I didn't do that very quickly, so let's do it and see if it's like this. And you can see that it is. But again, we do not see the paragraph print until we click the alert and close it. Okay? All right. So as mentioned here in this block, we grab a reference to a button element that's already available in the DOM. We add the click event listener to it so that when the button is clicked, it first shows us the alert message. Once the alert is dismissed by us basically clicking the button, we create a paragraph element, give it the content. This is a newly added paragraph. Then append or add that to our document body. While each operation is being processed, nothing else can happen. Rendering is paused. As said previously, this is because JavaScript is single-threaded. All right, only one thing can happen at a time. So in the example above, after you click the button in the paragraph won't appear until after the OK button is pressed in the alert. It says you can try it yourself. Well, we already have, but there you go. It is important to remember that alert, while being very useful in demonstrating an asynchronous blocking operation, is terrible for use in real-world problems, and it really shouldn't be used. Now, I think at least what still will happen, let's see if I'm right or wrong on this. I'm going to take this, and with this alert, you clicked me, and let's see, the document. Well, that's going to be harder. But let's see if we change this from an alert to a console.log if it's a lot more instantaneous as far as boom, boom, because there's nothing to close. So we'll go back to here. Oops, not to there. I'm sorry. We'll go back to here. We'll refresh. Click. All right. Do it again. You have to kind of watch them both. And it is, they're almost instantaneous. All right. For reasons we illustrated earlier related to blocking, many web API features. Now think about this. When they talk web API, again, that's an application program interface. That's not what's important. But the idea is if you are calling an API, whether it's one you wrote or are referencing or an external API, in a way at least, you're giving up control of the program. And the control is going to the API. And as it says, many web API features now use asynchronous code to run. Why? So so it doesn't stop you. There is no blocking, or the blocking that takes effect is limited. It says especially those that access or fetch some kind of resource from an external device, such as fetching a file from a network, accessing a database and returning data from it, accessing a video stream, etc. All right. Why is this difficult to get to work using synchronous code? It says, let's look at a simple example. When you fetch an image from a server, you can't return the result immediately. It says this means the following code will not work, because while it's doing the fetch, all right, while it's doing that, it's immediately trying to go and do this. Well, if this has not yet been fetched, you're going to get an error. So as mentioned here, it says this is because you don't know how long the image will take to download. So when you come to run the second line, it throws an error. It might throw it every time, as it says. It might be intermittent, but it doesn't matter. It'll be an error anyway because the response is not yet available. So you need your code to wait until it is available. So as mentioned here, there's two main types of asynchronous code styles that you'll come across in JavaScript: old style callbacks and newer promise style code. And with the newer promise, there are promises and there's async await. So we're going to look at all three of these. All right. So the first one is callbacks. And as mentioned here, async callbacks are functions that are specified as arguments when calling a function which will start executing code in the background. So in other words, what this is saying here, all right, is that when you click, all right, basically everything that's in here is the second parameter. It's invoked, as it says, when the event is fired. So let's take a look at the example. Let's see. So let's come in here and just try to grab this. All right, we'll come into here. I don't know if this is going to work or not, but why not? So I'm going to come in here and grab this and paste. Let's see. I think we'll just grab this. This is the add event listener. Yes. So we left in the button and we left in getting the reference to the button. But now what we're saying is, yeah, you click me, etc. And let's do this. Let's go outside of here and let's do let's try doing a couple things. Let's do a console.log where we just do a test. And let's do an alert where we've got a test. All right, just to see when we run this exactly what happens. In other words, does the click me come up first and then the console log and then the alert? So let's see. So again, I'm going to come in here and refresh. Notice that what came up right away was the alert and this. And then when we stopped, all right, now we get the you click me. Let's try it again. So let's refresh. All right, that immediately came up and so did that. I'm going to refresh again and watch because it's bang, bang. So I'm going to refresh again. And I click here. Okay. Nothing's happening because I haven't clicked the button yet. So I click the button. Again, this comes up, and after I close that, now I get the text. So again, the first parameter is the type of event we want to listen for, which is the click. The second parameter is a callback function that's invoked when the event is fired. Well, let's go back to the program and let's comment these two lines out. All right, we've saved. Let's go back into here again and refresh. You'll notice that that stuff is all out of there. Now when I click, it says you clicked me, and I get that. All right, so in other words, this and this did not take effect until we click this. All right. Now, as mentioned here, when we pass a callback function as an argument to another function, we are only passing the function's reference as an argument. In other words, the callback function is not executed immediately. It is called back. So we are telling it here is, hey, when you do click the button, run this. Also, notice the syntax on here. There's nothing being passed here. All right, so there's no arguments being passed to this. And this is sometimes called the fat arrow operator. So this is saying when you do this, you're going to run this anonymous function that has no parameters being passed to it. So as it says here, the containing function is responsible for executing the callback when the time comes. You can write your own function containing a callback easily enough. Let's look at another example that loads a resource via an XML HTTP request API. All right, so what are we doing here? Well, when we start to take a look through here, what do we have? Load asset. So let's see, we're calling load asset and we're passing in this coffee because it's expecting there to be a URL, the type, which is a binary large image, and the callback, which says after it's been loaded, call display image, which is right here. All right. So we go through, we run this, and we do this, and we do this, and this, and this, and here we're calling callback. So it says we create a display image function. Let me make this a little smaller so you can see all of it here. There we go. There we are. So here we create a display image function that represents a blob passed to it as an object URL, then creates an image to display the URL, appending it to the body of the document. However, we then create a load asset function that takes a callback parameter along with a URL to fetch and a content type. What you're trying to do is to keep stuff in sync here, for lack of better words. This uses the XML HTTP request, also known as an XHR request, to fetch the resource at the given URL, then pass the response back or to the callback to do something. In this case, the callback is waiting for the XHR call to finish downloading. Now, it mentions here, I'm going to run this in just a second, but callbacks are versatile. Not only do they allow you to control the order in which functions are run and what data is passed between them, they also allow you to pass data to different functions depending on the circumstance. It says, so different actions could be run on the response downloaded. All right. So let's take a look at this. And it says that we can run it live. So let's just run it. Okay. And it is showing us an image. So again, we can grab that code as well. And I think it's going to look very similar to what we just saw, but that's okay. So let's refresh. And we get access to this request has been blocked by CORS policy. We're not going to get into CORS right now, which, as it says, is cross-origin requests. But it says it's only supported for HTTP, data, Chrome, etc. All right, so in other words, when I tried to run it, it failed. Not all callbacks are async. Some run synchronously. An example is when we use the array prototype for each to loop through all the items in an array. So here it is. In this example, we loop through an array of Greek gods and print the index numbers and the values. So this should print basically 0 Apollo, 1 Artemis, 2 Eris, 3 Zeus type of a thing. All right. However, it doesn't wait for anything. It runs immediately. Now, I don't disagree with that. I don't disagree with that at all. But that said, we're also only printing 4 things. Would that be different if we were printing 4 million things? If that would be the case, we may want to sit there, and while that stuff is loading, we might want to have the ability to go on and do something else. I'm going to grab this, just remove what's there, replace it with this simple thing that we've got here. All right, I have no idea if this is going to work or not, but it should. And there they are. All right. And that's not to say that when you do something that you can do synchronously, it's not to say that you could not do it asynchronously. One of the things I believe we'll talk about when we get to the end of this is what you should use, why you should use it, type of an idea. All right. Now that gets us into promises. I'm at 18 minutes, so I will start talking about promises in the next lecture.